Welcome to Debug Diaries by CSE, a podcast where we dive into the world of technology with some of the most influential minds shaping its landscape. Join us as we explore the past, navigate the present, and envision the future of innovation and technology. Today, we are honored to introduce Professor Sanath Jayasena, a distinguished figure in the technology field. As a member of the inaugural batch of the Department of Computer Science and Engineering at the University of Moratuwa, Professor Jayasena has seamlessly bridged the realms of academia and industry. His extensive career encompasses roles such as the head of department at CSE and his current position as director at Intervest Software Solutions. Professor Jayasena's expertise spans high-performance computing, parallel computing, machine learning, and natural language processing, with particular focus on the Sinhala language. His contributions have significantly advanced the technological landscape, exemplifying a commitment to both theoretical innovation and practical application. So, good morning, Professor Sanath. Very glad to have you here on board Debug Diaries podcast. So, how are you feeling today?
Good morning, Ovidu. Thank you very much for having me in this Debug Diaries. Feeling very good. Yes, I'm privileged to be here in this occasion. Thank you for inviting me.
Right. So to begin with, sir, we'll talk a bit about how your life before you came in to the Department of Computer Science as an undergraduate. How was it like? What intrigued you to follow into the path of technology?
Well, I think I was I have a common story. I think for with so many others who are coming into the university and in this career. I think I was interested in mathematics, obviously, and I wanted to. I had vision of becoming an engineer. One day when I was at school, I was thinking like that, and I also was very much keen in. Very much fascinated with technology, how it can change the world. So in the early days, so I thought it's coming to a university and studying technologies would be something a life dream that I had.
So that is very, very interesting. And you were from the first batch of computer science and engineering at the University of Moratuwa.
Yeah.
So
Yes.
my next question is, what really made you join this very new and untested field when it was introduced at the University of Moratuwa?
Yeah, indeed, I was in the first batch. So actually, I wanted to come to Moratuwa because by that time I think there was some recognition about Moratuwa that they are doing something innovative things and they are pioneering certain things in technology. So I wanted to be at Moratuwa. I was fortunate to be at Moratuwa. Then when I came here, we got to know that there's a new degree program in computer science and engineering they were to start. They wanted to know whether I would like to join it. So I actually thought about it, and I felt that would be a very good opportunity for me to have maybe an advantage, perhaps also maybe opportunity. While also I talked to some colleagues, and at that time some were a little bit reluctant to get into that. Maybe they were thinking it's a new program. I don't know how it will end up and things like that. They felt there was a risk in something, but I didn't feel that at all. I thought maybe that is the case, but here's an opportunity for me to learn into new things, and it's you don't get many chances also. We had a batch of about 230 students in the engineering intake. Only 16 were admitted, so I was fortunate to get admitted into that.
So the Department of Computer Science is known nationally as well as internationally for the students it produces. But when it started, it was just 15 students in the department. So could you mention a bit about how it was navigating those early days at the Department of Computer Science and Engineering?
We actually had 16 students. So that 16 was the number because of the capacity in the department. With limited human and other resources available, they felt that 16 is the number. But during the time, they have lots of problems in the country also. The universities were closed for a long time and so forth. One student left for higher studies outside the country, and we had 15. It was a very closely knit group. We were working together, and all were very bright people, brilliant people. So I think, and interestingly, we could work together in many things because we were a small crowd, and we had to. Also, the department side, we had various people from outside the country coming in and teaching us because of the lack of human capacity in the department those days. They were actually that additional academic support was provided by a few individuals who were here from outside Sri Lanka. There was Professor Induru, who was the head of the department, founding head, and we had several other staff members. Now Professor Gihandas, while we were students, he finished his PhD and came back. And there was also late Professor Vijay Soma, who later went into Singapore and who passed away a few years ago. Those were initial senior academics whom we remember. They did a very good job in molding us and training us and making us the way that CSE graduate should be. So I think it's a wonderful experience. And even today, so after so many years, our first batch and very much closely bound together, and we meet from time to time. And we had a recent event for the 40th anniversary inauguration event. We had about more than 50% of that first batch joining there in that event. Yeah.
Right, sir. So as you mentioned, there were some great individuals who molded you and who molded CSE from its inception. And from the first batch, you and many others went on to match the legacy of many of these great individuals. And you too ended up being appointed as the head of department at Computer Science and Engineering. So could you mention a bit about your experience as the head of department at one of the biggest, if not the biggest department for computer science in Sri Lanka?
Right. Yeah. So after I passed out of the university, I joined the department because I wanted to be. I thought at that point I wanted to be an academic, and so I got this opportunity. I feel very happy about it and proud of that, being able to join this department. And I came back to Sri Lanka after completing my PhD in 2003, and soon after a couple of years, I was asked to take over the head of the department position. Initially, I thought I still feel maybe if I had more time to adjust, and because not long after I came back from with PhD, I got this. In a way, it's kind of a challenging situation, but I had to do it as well. That was the expectation. So it was at the time we had about 50 students intake at the CSE department, and we had a reasonable number of staff members also at the time. So I think we could really continue our work, the good work that was going on, and we could lay the groundwork to double the intake also in a couple of years later to make it 100. So that also happened. So I think, and during that time also we started our master's programs, the MSc in computer science. Actually, just before I became the head, Dr. Ashok Piris was the head. So during that time we launched the MBA and the MSc programs, which are first postgraduate programs in the department. And gradually we improved that as well. So I think the industry contributed to the country and the industry in during that period, also continuing our legacy by expanding into postgraduate programs as well.
Yeah. So your work not just limits itself to the Department of Computer Science at University of Moratuwa. You've also done research in multiple fields and in multiple places. So one of these places is the University of MIT, which is known as one of the best universities around the world. So could you mention a bit about your work at this prestigious institution?
Right. Windu, I did my first the graduate studies, my PhD I did in the US at University of Illinois. That's in the middle of the US. So after a few years back in Sri Lanka, around 2010, around 2011, I got this opportunity, great opportunity, I would say. Actually, this was made possible. I must gratefully acknowledge Professor Saman Amarasinghe, who is a very well-known, reputed academic in computing. I think I would consider the greatest computer science expert produced by, I think, Sri Lanka. I think Professor Saman Singh is a professor at MIT. So we had some communications going on for some time. He was a known figure here. When I was, for example, a student in the department, most of our students, we benefited from the books that he had actually donated to the library those days, I remember. So anyway, he basically said there will be a possibility of somebody from the department to come and work with him on sabbatical. So I went there in late 2011 and stayed about 12 to 14 months period sabbatical leave spent with Professor Saman's compiler research group. And it was a very enriching and wonderful, incredible experience. I would say, yes, it's maybe a dream come true for somebody in the technology field to be at the top place in the world. So it was actually, we could experience, we can see how teaching, research and other knowledge creation exercises, how these things are happening in a top university in the world. And I was part of many things. I got involved in teaching. I followed some courses. I also got a lot of research work going on. That was the main task I was doing. And it was a very enriching environment. We could, in addition to all the normal academic things that are happening, that's also lots of industry collaboration and also with collaborations and visits and various events taking place with various visitors coming in. So every week, maybe every few days, we would see somebody's talk, maybe somebody from Google, somebody from Intel, somebody from Microsoft, or from other top universities in the world. So these things are regular things. So it's an incredible experience. I really am happy that I got that opportunity. I think I learned a lot, and it was a huge growing experience for me. I really appreciate that opportunity.
That is a fascinating story, and I'm sure most of our viewers would be dreaming of, one day going to MIT, which is one of the pinnacles of the technological world, right?
Yeah, some of our graduates have gone there and completed the PhD there as well. Yes, happy to say that. Yeah.
So while you did research, I think one of your main fields of research is NLP, which is known as natural language processing. So currently the trend all around the world is, talking about these LLMs. But before LLMs, we had NLP. And could you mention a bit about what were the earliest attempts to make machines understand natural language and how that evolved into the LLMs that we all use in today's time?
Right. So NLP basically means natural language processing. It's how we use we can say a field within computer science and AI. It's about understanding and interpreting and generating human language. So this involves maybe understanding and generating textual things, plus also speech. So I think from the early days in computers, people tried things. So they used various, depending on the technologies available and the knowledge they had those days. Early attempts were very much, it's basically a computational exercise. So how would you represent language? How do you analyze them? What kind of structures are there? How do you understand the language and things like that? So over time, I think many years went by, various attempts were there. how to, for example, you give a text written by somebody, and can a computer understand and extract information from that, for example, right? And identify some, let's say, if you mention some nouns, uh, some names of people or places, how do you extract that information? Things like that. Or you try to have a conversation. Can I talk to a computer, and can the computer understand and have a dialogue with me? Of course, those things like the having dialogue and things like that were quite challenging in the early days. So, but I think past 24 months, I think has changed that domain hugely. I think in leaps and bounds, and maybe couldn't have been imagined a few years ago. But I think if you recall some of the things like there's something called Turing test, right? Earliest days, Alan Turing actually proposed how to measure the ability of a machine by checking, testing how much a machine can mimic the behavior of a human. Let's say a computer is behind the wall and we don't know whether I'm interacting with a person or a computer. I would send a message and I get response. So that's basically the ultimate test of a computer, whether how well a computer can mimic the behavior of a human. So now we actually see that it's actually happening to a great extent. I would say, yes, it's not definitely not maybe perfect, but there is very much, it has grown tremendously, and we could see a very good performance in language generation part, understanding, having conversations, all that. So one few causes behind that is the huge amount of data that we have out today, plus the growth of the internet and the technology, then the ability to handle lots of data, and the growth of computing power. All these things have made these things possible. Yes.
So, as you mentioned, one of the things that made this leaps and bounds in this NLP field was the emergence of high computing power. And this is where we talk about, high performance computing, another one of your research fields. So, can you mention a bit about your work in this field of high performance computing?
Right. Yes, I was interested in this area for a while, and I have done some research on this. While I was at MIT also. Some of the work that Professor Saman was doing and his group about high performance computing related things. So yeah, that's actually made certain the importance of high performance computing is that okay, there are certain problems that the scale of the problem or the amount of data you have is so big that at certain points in time, people felt that, okay, we can't do this, or it was unimaginable. But later on, as technology progressed, we had more and more powerful computers, the processors, and after some point, we went beyond a single processor, and maybe tens or hundreds or thousands of processors working together in parallel and distributed manner. So, which made it possible to solve lots of big scale problems. Right, so that's a basic thing about high performance computing is how much computation you can do within a small amount of time, right? So, and with a huge amount of data, actually you could do try to solve so many real world problems which are out there, from maybe basic sciences, various research that's going on in basic sciences, to real world problems like weather forecasting, and maybe about human body, human genetics related things, and so many things out there. Earlier that was not considered possible, was becoming possible because of this increased computational power. So parallel computing is very much part of it. So I have done some projects about this thing. I just want to mention one thing maybe about the performance tuning of systems or programs. There was one project that I got involved in called Open Tuner when I was in MIT, and later on we did the undergraduate project here based on this Open Tuner, where okay, let's say we write a Java program and we have a particular system computer to run that Java program on. And now, do you know that the Java compiler, if you want to really generate a code to, a compiler works. So compilers these days are quite sophisticated, but the compilers also allow the programmer to choose various options, tune it, and to make it run the way you want. Maybe you want to run it as fast as you could, or maybe taking generate code which take small space as possible. Things like that. You could do that. The thing is that interestingly, some of these compilers have so many options. Sometimes it may be not dozens, maybe hundreds of options. And then how do you choose the best set of parameters? So that's actually a tough problem. So what this OpenTuner provided was basically a effective way. It's kind of that involves a little bit of a searching and learning also. Identify a good set of parameters for a given problem and to generate code that is optimized towards that. So we had the undergraduate project where we tried to optimize Java compilers parameters. There were about 600 odd options if you want to go and choose. And so how to tune it and find the best possible parameters for a given situation and produce code that's optimal. So, and we ended up in a good research paper, and the undergraduates, two of them who engaged in that exercise went on to complete their PhDs also later on. So happy about that project here.
Right. As fascinating as your work in academia is, you did not stop there, and you also work in the industry as well. So could you elaborate a bit about your role as the director of Intervest Technologies and what exactly is it that you do?
Right, that's another completely another part of my professional life, I would say. So one thing when I came back to the US from the US to Sri Lanka after completing my PhD, one thing I really was interested in seeing that I could see the potential of our our human resource. There are many good talent in the country, and we could see from the students that we are getting into the department. So one thing I was very keen in see whether we can I can get involved in the industry to basically utilize this talent and maybe contribute to the growth of the economy and the industry here. So when I was considering that, I got the opportunity from two former students from CSE. Actually, they invited me to be part of a very small operation at the time. This Intervest, actually, the name was not there, but they were doing something with the British business colleague. I would name his name is Ryan. So we were very happy I was happy to get involved in that. They basically wanted somebody like me playing some senior role and being a director. So I was happy, but we didn't really at that time didn't realize that it will grow that big. But that was, I would say, about 18 years ago. So we started very small. We had a small office in Moratuwa with about 10-12 people. And we grew gradually, and with the support that we provided, the technology that we developed, the talented people we had and all that, the business, we were basically the technology arm of an insurance, travel insurance related company in the UK and in the Europe. And with our support, basically the business also grew there. So it was a kind of a mutual thing. With that growth, we also expanded, and we had observed rapid growth in the past couple of years since COVID also, and now we have about 300 plus people. So I'm playing the director role there and looking at more strategic and top level management kind of aspects. I don't get the opportunity to get involved in the technology development itself, because I play a dual role because I have my work at the university, but I have to play some role there also. So that's how currently it works.
So you are an individual who, as I mentioned before, seamlessly bridges the gap between academia and industry. So could you mention a bit about, how you see this mutual benefit, from academia and industry, and the connections you make and the technology and the knowledge that is shared?
The interaction will definitely be a kind of a synergy thing. I see that because when you get together, you can do so many incredible things. that you cannot do otherwise. I mean, if you are working alone. So here, for example, in a university setting, we want to train and build the next generation of workforce who will contribute to the economy and also maybe to solve various problems that for the humanity, right? So I think we get lots of talented people coming in. So for that, we need the support of the industry in various ways, because academic is just one part of the training. So we want constant interaction, and even the things like internships and other mentorships kinds of arrangements are very effective, very useful. They are essential, I would say, to develop, grow the talent and develop, train our engineers. So, and plus, and the industry is always looking for new talent, because people, every year some people maybe you can see people are leaving, or some people getting retired or something, and then we have new problems, and the problems they have to solve basically get scaled up, and they need more people. So all this time the universities are the place to produce that workforce. So for that, in the best interest of the companies, the industries also, to see that they are getting the best talent, so that they can contribute. So constant interaction and working together is a very important thing in developing our talent.
Right. So from the inception of the Department of Computer Science and Engineering to, as you mentioned, it's celebrating 40 years of CSE. You've been there and you've seen it all. So can you mention about how you've seen this department, develop from its infancy to where it is now?
Yeah, it's very happy to see all that. Back then, as I said, about 16 students. There were few batches that had just 16 only. And the staff numbers was also like a handful of staff members. And we had to rely on some people from outside to teach our students and all that. From that, and so space-wise, we occupied only a small area in the Moratuwa building, second floor. And we were actually, the time we entered the university, the smallest department in the faculty with 16 students intake. Now, 2025, we are the largest department in the faculty with 200 intake. So that itself shows just numbers, how we have grown and how the world has changed and how the university also has changed. So I think that's a good thing about Moratuwa, I say, because one thing I noticed when I came into the university, no other university in the country had, I think, thought about this, having a separate degree program for computer science and engineering, and as well as I had to also mention the textile technology. Now, when you look at the Sri Lankan economy, two fields that play a crucial role is basically apparel and IT. You can see, I think that's I think a great vision that the earlier University of Moratuwa leaders had. I think the many people there, they, I think, felt that this is something that they should do. So it's not surprising that we have grown this way. And of course, many people who were here, staff and our students, have basically made it possible, because if the students who passed out from here and go out there and perform well, if that didn't happen, this wouldn't have happened also, because the industry, what we have seen over the years, is always telling us we need more people from Moratuwa, more people from CSE, like that. So we went from 16 to 24, as I remember, because there was some period I was not in the country. So then we went to 50 number, and then went to 100, became 128, and finally to 200. So that's an incredible journey as a department over the 40 years. I think we can be very proud of. I think our department as a whole is playing a crucial role in the national landscape, contributing, I think, tremendously to the national economy.
It's fascinating to hear about how CSE has grown to what it is today. And as we wrap up what has been a very insightful conversation, we would like to ask you, Professor Sanath, what do you see as key factors, key skills that a undergraduate or even a professional that is navigating today's technological landscape should possess, given your experience in the industry over the years?
Okay, so this is a question that have been asked over the years. There are some key things any student should basically try to have to build in themselves to be successful. I think one is basically that you should be quite good at your basics and the fundamentals. I think computing, there are many high level things now which are actually at the field has grown quite a lot, and you can actually try to study certain things at the very high level. Maybe there may be a trends to do some trend about that also, but I think you can't do this thing effectively without knowing your basics, the fundamentals. So I think very important to know the capabilities and the limitations in computers. I think that's a very important thing. And I think anyway the students who come into the program has the mathematical and analytical capability. You have to sharpen those skills very much. That's also very important. The other thing is about doing projects that are maybe that real world problems, trying to solve them with computational approaches, with the technologies. I think you can't basically cover all the technologies out there in the world today, but whatever you do, you try to go deep enough and apply those things as much as possible. So gain experience in solving problems and doing projects. I think that's another thing I would say encourage people to do, because when it comes to, if you go to a interview or if you are looking for a job, people would want to know what projects you have done, what kind of problems have you solved. Plus, the other thing is balancing. I would highly encourage people to balance all these things, these academic things and technology things, with other things that is out there in the life. Is to be be a social person, work with your colleagues and other people, the community, closely with them, and organize events, participate in those. Be active person socially and doing other things, and enjoy your life also.
So as we conclude today, we would like to really thank Professor Sanath for being here today and sharing your journey, your insights, and your advice with us and our audience. So thank you once again for being here and sharing this invaluable knowledge that you have with us. And to all our listeners of the podcast, thank you for being with us throughout the episodes of Debug Diaries. We hope you have got something from this episode, and we hope to see you again on the next episode of Debug Diaries by CSE. Thank you.